Today we are continuing in our discussion about polymorphism, how it works, all this fun stuff. So, brief recap of what we talked about last class. Polymorphism is the capability of a method to do different things depending on the object upon which it is acting. We can make variables with a superclass type as their reference type that have a subclass type as their object type. So we can have a variable where the reference and object types do not match up. And one of these principles of polymorphism states that Java can call the correct method even when an object is disguised as a more generic reference type. So in order to ensure that our polymorphism is implemented correctly, there's two different times during which our code is checked to make sure that our polymorphism is working right. During compile time and during runtime. Compile time is when the program called the compiler reads through our code and generates an executable for our program to actually run. Errors are checked for during compile time, and if there's an error, your code will not compile correctly. After our code is compiled, then we can run it. So those are the two different times at which our program is checked. So let's talk about during compile time. When the program is being compiled, methods that are in or are inherited by the reference type determine the correctness of a non-static method call. Let's look at an example, maybe explain that a little bit. So if I make a variable called myPerson, I give it the reference type person and the object type student, and I call myPerson.getName. In order for my program to compile, this method, getName, must be defined within my person class. At this point, it doesn't matter if it's defined in the student class, it only needs to be defined in the person class. If it's not, our program will not compile. So if we have a method that's only defined in our student class and we try to call it here, our code won't compile. And then during runtime, the method in the object type will be executed. So when I call myPerson.getName, Java is going to look inside of the student class first for that getName method. So if getName doesn't exist within student, then it will check in the superclass person, but it will first check in the object type rather than first checking the reference type. So let's look at a slightly more in-depth example to get a better idea of how this is all going to work. So if I have two different classes, I have my person and my student. I've kind of slimmed them down a little bit. Person just has a name, student just has a grade. We've gotten rid of some of the other extraneous pieces of information. Our person constructor fills in the name variable, and it has a method called printName, where we print the word name and we print the value of the person's name. And the student class, our constructor gets the name and the grade. We pass the name to the superclass, and we fill in our grade. And then we're going to override the printName method. So both person and student have the printName method available. Student's printName prints that word student, and then it calls the superclass's printName method. So, like I said, both of our classes here have this printName method. So if I create some other piece of code, it's actually going to run these, I'll call it person runner class, in my main method, because that's the piece of code that actually starts when we click run. Let's say we make two person type objects or person reference type objects, Jobs and Lovelace. We talked about these same variables last time. Jobs is a new person with the name Steve. Lovelace is a new student with the name Ada, the grade 12. So when I call printName on each of those different variables, during compile time, since they are both declared as person type objects, Java is going to look, or the compiler is going to look in the person class for print name. If print name is defined in the person class, the compiler is happy. Doesn't matter what it does, all the compiler cares about is whether or not it's defined in that class. So the compiler sees print name is defined in the person class, so we will continue to run it. When we are running, Java is going to look in each object type for the print name method. So jobs is a person, so it's going to look in the person class when we call print name. So when I print jobs, it's going to just print name jobs. And when I call Lovelace.print name, since Ada or Lovelace is a student object type, Java is going to look in the student class for its version of that method. So it's going to print the word student and then jump into the superclass version and print name Ada. So our output, name Steve, student name Ada. So because they are different object types, even though we're calling the same method, since it's implemented differently in both of our classes, we're going to cause something slightly different to happen in each one. Yes?
Why does it still say name in the second line? Like in the output, when it's printing it?
Because we are from our subclass, we're printing the word student, and then we're calling our superclass's print name method. So we're jumping up into here, and so our name is Ada, so we print the name, the word name, and then their actual name. All right, so if I update my example and I change the print name method in my student class to be print grade, where I just print the word grade and then the value of that variable. And then I update my person runner's main method to say jobs.printName, Lovelace.printGrade. Once again, at compile time, the compiler is going to look in the person class, because that's what both of them are defined as for both print name and print grade. Is print grade defined in the person class? No, it is not. Therefore, we're going to get a big old error saying, hey, we can't find that method, we can't find print grade in the person class. So there we have it. We can't call methods that are exclusive to the student class when we've defined a variable as having reference type person, but object type student. So question is, why bother with polymorphism if I don't have access to my student class methods or my student class exclusive methods? Why bother making Lovelace a person rather than making Lovelace a student? If I do student Lovelace equals new student rather than person Lovelace equals new student, I have access to that print grade method. I can use it however I want. The answer is, for scope purposes, sometimes we need to create our variable before we know what kind of object we're going to get. Especially like if we have our array or an array list of objects, or if we're getting a parameter to a method, we don't know whether it's going to be a person or a student when we're trying to store it in this array or passing it to this method. So having this flexibility, being able to accept either one, makes it a lot easier for our program to work. Now, if in this program, I didn't try to call print grade, my code would run just fine. I can have methods defined in student that aren't defined in person, as long as I don't try to call them when my student object variables are not declared as having a reference type of person. So as long as they're not trying to call the student exclusive methods from my person reference type variables, we're okay. So we can avoid these errors of not having this method exist by either A, implementing those methods in our superclass and then overriding them in our subclass. So sometimes this is useful. In this scenario with the person and grade and student, that doesn't make a lot of sense because a person object doesn't make sense to have a grade to get. So that one doesn't really fit this solution. But option B is just avoid calling those methods that are implemented in the subclass, but not in the superclass. When I'm working with person type reference objects, reference type of person objects, it wouldn't make sense to try and call student exclusive methods. They just don't have access to them. So when we're working with an array of person type objects, or if we're working with a method except as a person type object, we should only try to use methods that are usable by a person type object. Otherwise, what are we even trying to do? It doesn't make a lot of sense. So, recap of what we've talked about today. When we compile the program, the methods being called in your code must be created within the class of the reference type. Otherwise, the code will not compile. And then when our program is run, methods being called are going to look at the object type to determine what actually is going to happen. If the method is defined in the class of the object type, that version of the method will be called. If it's not present there, it's going to look in the superclass, find it there instead. All right. Any questions on how polymorphism works? All make sense? Cool. All right. Then I will stop the recording.